what service chaining is, or for example, how it can be used to look at the enterprise IT opportunities, networking towards enterprises, and that would take us into use cases like a virtual enterprise gateway. Am I right to assume that that would be a little bit too much detail now?
Are you going to go into some use cases, operator use cases tomorrow?
There will be some more use cases tomorrow, I think. But then you not really? Okay. I thought, okay, you will not do that.
Not in this.
Not in this. Okay. Let me do it this way then. Just to give you a little bit of a hint, and then I'm happy to take questions separately from any one of you, or have a follow-up as well. This is, of course, extremely complex, even if you simplify it on this slide. But what it really tells you, and we showed this in the Broadband Forum just a few days back, a few weeks back, is that when you start to make the network programmable, operators ask themselves questions like, do we really need those home gateways in everyone's home, or can we centralize some of that function? Well, you can make a virtual home gateway and put it into the network, where you have all the NATing and firewalls and everything. You make it a network function. Saves OpEx, and in some cases CapEx, and it's much more easy to manage. What if we do that also for the enterprises? Can we take some of the functionality out of the enterprises and put it into the network to save cost, increase flexibility? Well, we can. Let's call it a virtual home or enterprise gateway. So these use cases, they are worked on by us, of course, and some of our leading customers in terms of demos, tests, trials. And for you, I think it's more to show that the industry is seriously working on the most relevant use cases. It is not to give you a flavor that this is the only use case that you will see being deployed. It's rather one example of how this technology can be used, so that you move functionality out of the enterprise into the edge node, and NAT firewalls, web filters are controlled by packet inspection, that with the controller selects which route the packet should traverse, and it's all given by the policies that the IT manager or even the user has provided in that self-care portal up to the left. So you have full automation with full visibility, and also self-care to reduce further the cost. So these are just examples of what you can use this technology for. And here you also see that, in this case, the ECS stands for Ericsson Cloud System, which is Ericsson's way of building all the applications into all our infrastructure, based on open source, based on KVM, based on OpenStack. Is our cloud manager that manages all these resources across the network. It decides where virtual machines should execute, centrally or distributed. Is it a game that you saw out there that needs to have latency optimization, or is it bulk data transfer that you do more centrally? All of those decisions are made on the fly. So I'll try one more concept on you, and you hit me in the head if it gets too detailed here. Because when you have all these things in place, when you have the flexibility to control the network, and you have a cloud environment that can be both central as well as distributed, how does anyone outside of the communication industry make sense of it? You don't need and want all those buttons and controls and SLAs and everything if you're an enterprise user, or you're a media company, or you're a gaming company, or you're somebody who simply just want to have your service work well at low cost. So as an industry, we need to come up with a way to present these capabilities in a coherent way. And that's what we call network slicing. So the network is one and the same logical network. Whether you use it for broadcast with LTE broadcast all the way out to the devices, instead of a separate infrastructure to do broadcasting, everything is in the same network. Whether you use it for managing a fleet of trucks, or for safely guiding cars down the highway, or for any other application that any of these other industries would like to have passed through the network. We need to be able to segment the network's resources into network slices where we're not only talking about QoS in the bandwidth, we're not only talking about the latency, a megabit per second, we're also talking about compute and storage. And compute and storage, that is the same as cloud, which is the same as caches further out in the network. If a user needs to have a cache further out in the network because it should be low latency for his app to work well, then this network slice provide resources, compute and storage out there, and make sure that the network follows it. It may sound a little bit like magic. Today we can do it. I think we have a demo that we can show if somebody's interested of how this would actually play out from an enterprise user's perspective, from an IT manager's perspective. But we are putting all the pieces together to make this a fully automated process. And it allows us basically to get all of these capabilities into a manageable and explainable form to anyone outside the network. Has anyone heard of the concept network slices? I have to just check with you. Yeah, there's at least one there. Okay, 2, 3. We're somewhere on the way. This is something that will take time, as you understand. This is something that we are building together with other industry players in order to have enough industry momentum. And it's closely related to how the network is presented in terms of APIs. How do you connect to the network? But it's also very connected to how the users actually interact directly with the network. How web portals, self-service portals, and SLAs from an IT manager propagates into the network so that the right resources are set up. So, I think that, and there are some differences between virtual private networks and network slices. Leave that. Talk a little bit about open daylight and what we're doing there. Our very strong member there. I think here we should not go for the video. I think anyone who's interested in...
they can stay.
They can stay. We can do that. We should do it that way. So we allow you to look at the video how network slices work in reality. I'll be happy to show that. But before that, any questions? Yes?
Where does the device fit in this virtualized SDN? In other words, the device has processing memory and the ability to be virtualized.
Yeah.
Does that fit within your paradigm? Because I haven't seen it in any of the network diagrams.
Yeah, it actually fits there, but in 2 ways. One is in the way that all devices that, when we talk about mobility, we talk about mobility both in terms of network as well as a device. So it's, in that sense, it's part of the biggest domain, the mobility domain. Devices, whether it's smartphones, tablets, sensors, together with mobile infrastructure. That's the mobility domain. Now, there is also possibilities to use that memory that's out in the device. So some of these examples where you move data further out in the network, they are also related to what you broadcast or provide to the device. You can pre-store things in devices so that video viewing is significantly enhanced simply because it's already available in the device. Those technologies, they are now very much explored, and because there are things already available. I would say that on a more industrial base or industrial size or scale, I should say, it is still very early days. It's something that's being tested and trialed together with leading customers.
But are the device manufacturers participating in these initiatives, or is it more one of saying that the device is something that will be incorporated in it according to the standards?
Well, as I said, so far, most of what is covered on the device side is also part of the mobility space, which is then, when it comes to access and what you actually have to do, is part of those standards that we talked about earlier, the 3GPP type of standards. When it comes to the application piece, any of these ecosystems that we interface with, every one of the big big brands, social media, social networking, media companies, search companies, all of those, they have some client part. There is a part on the device side that needs to be optimized together with the network at the back end. So you are interfacing from both ends. You're interfacing towards the device platform on the network, on the device side, and you're interfacing towards the network platform on the network and back end side. So it goes hand in hand.
Yeah. It just kind of there's a sort of a general assumption almost that the device is distinct from the network, which isn't necessarily the case when you look at SD cards that standardized all the way to 2 terabytes.
Yeah, I agree.
It's,
There's plenty of opportunity to explore more of that distributed capability. But you're also now a few steps ahead, because I think we have to take this very much stepwise, and that's why I try to point out that as we are commercializing this now, Ericsson is leading this commercialization of service provider SDN and the telco data center, what we can do in terms of virtualizing all the applications. This is a stepwise approach, where robustness, resiliency, maintainability, all the operational aspects have to mature at the same pace. And I showed this slide about the technology versus the business versus the operations. And it's very true that this is an exercise that will take some time. Over time, we will have all those additional benefits that we are more consistent across devices and networks and central data centers. You're right. Okay. Any other questions? SDN now. Any remaining questions on SDN that I need? Yes.
I would like to ask the network functions virtualization.
Yes.
Today's 3GPP interface not made for the virtualization technology. Not made for the virtualization.
Correct.
Yeah. I think there is some work sequence. I think it must be changed. How do you think of it?
Well, it's true that the architecture that 3GPP is working with. 3GPP, maybe everyone is familiar with it. 3GPP is the standardization body, global standardization body that specifies the LTE and 3G HSP and so forth. It also specifies the nodes, functional nodes, like what you do in a packet core, what you do in a base station and so forth. That is a functional architecture. That does not tell you how to implement it. In fact, operators and certainly vendors have had different implementation choices even with that functional architecture. So in Ericsson's case, we have since a long time built our core network nodes on hardware that is separate from the software in a Linux environment, which allows us to move into an NFV world easier perhaps than others. We can still comply to those functional specifications in 3GPP. We can still comply to the interfaces towards other vendors or other networks, but we implement it in a more flexible way. So that is the short answer. The longer answer is that over time, there may be requirements that cannot be met with current specifications, and we'll have to change them. But as we see today, let's not mix functional architectures with implementation architectures. Okay? Anything else? So what this slide says as a conclusion of this late afternoon session is that Ericsson believes that the cloud infrastructure, whether telco data centers or even other data centers further out, needs to be combined with the networks. Because of the mobility that is driving much of the user experience, these two needs to be combined. And we have an excellent position from Ericsson to drive this convergence, mobility and cloud combined. And both the network virtualization, network-enabled cloud, as well as Ericsson service provider SDN, are the big tools in the toolbox that we need to be able to do this. So we combine the cloud and the mobility with the help of SDN and virtualization. This would not be enough if we didn't have a certain openness towards new applications and network functions that are not only built by us. That's why it's an open environment. We build on OpenStack, we build on standard IT environments when it comes to building new applications, still with the added value of network quality. But we also need these applications, particularly those media applications, the applications that come from a gaming company, from a company that has extreme latency requirements, maybe for the self-driving cars, to propagate down into the network. There cannot be a disconnect between the applications and the networks. There is no future for advanced applications if they don't reach into the network and become network aware. In the same way as networks have to be application aware. There's no meaning in providing only certain bit rates through the network if it's not tied to an application. That is the learning of the telco industry on one hand and the disconnected IT industry on the other side. Now they absolutely have to come together. And one way to do that, as we have explained, is via network slices that presents this capability that we have in the cloud and in the network in a meaningful way, so that you with SLAs and with full automation can reach into the network. So that is a short story, but a lot of words down in the technical details. And any more questions? I'm happy to take them afterwards. I think we should let everyone leave it.
It's not about SDN, if that was an issue. It's about the LTE radios in general. One of the strongest points of LTE was that it's a common standard for the whole world, where you can see the fragmentation of the frequencies in use.
Yep.
To what extent is that an issue for the industry? Because if you want to make handsets that can be used anywhere around the world, with the quality of service that people are wishing,
yep,
there's an issue.
But not so much any longer. I think we've touched a little bit on that before. Our biggest problem in the industry is scarcity of spectrum.
Yeah.
So we'll take any spectrum that governments provide. And that means that we have built networks and we've built devices that can handle very many frequency bands. They don't have to be globally aligned any longer. We can still have Japanese-specific, Korean-specific, and so forth. But the advantage is still there. If we harmonize, if we have broader reach, then the cost for everyone goes down. So there's no technical limitation, but there is a cost curve that you want to ride. And therefore, harmonization is still very, very good. Okay. Thank you, everyone. We should relieve you for some dinner.